All right. So let's take a look at the vector equation of a plane, right? So as I said, we did vector equation of points, we did vector equation of a line. Now we're going to have a whole set of lines, and those lines will form what we call a plane. We're going to find the vector equation of that plane. And I zoom. Zoom is that. Now again. Now it's just zoom on. Something wrong with zoom. It's a little glitch in the matrix. All right, nice. So let's take a look at a plane, right? So let's say a plane, as I said, a plane is a sheet of paper, right? What do we need to get the equation of that plane, right? So we're trying to get the vector equation. Trying to get the vector equation of a plane. Right? So as I said, in 3 dimension, right? A plane is just a piece of paper, right? Like a one sheet of paper. We're trying to find the equation of this plane. Right? How do we get the equation of that plane? We need 2 things. We need something to give us direction. So what we use is a vector perpendicular to the plane. Let's call it N. E is perpendicular to the plane. Right? Then we do the same thing again. Just as before. Just as before, we get a point on the plane. Right? Let's call that point A. Right? And we know that point, and then we have some random point R. Right? Let's draw them. Right? Let's draw them relative to the origin. Right? The vector AO, right? The position vector AO, let's call him small a. And the vector position vector ROR, let's call it small r. Right? So can we find AR? The reason I want to find AR is that remember we know this relationship. If 2 vectors are perpendicular, what we know? If 2 vectors are perpendicular, what we know? We know that the dot product is 0. So it means that if I know AR and I know this vector, when I multiply them, I'm supposed to get what? Right? So we know that E dot B is equal to 0 if perpendicular. So that's the reason why we're going after AR. Right? So AR is what? AR is vector AR is A to O, O to R. So it's A to O plus O to R. A to O is minus A, and O to R is R. So we can see that AR is equal to R minus A. Are you okay with that? Yeah, that's a rule. That's a rule for 2 things perpendicular. Yeah, that's a general thing. Yeah, that's general. So, right. So since AR is perpendicular to N, then we can say that AR multiplied by N should be 0. Okay with that? So AR is this. Right? And well, N is that. When you multiply it out, what you'll get? You'll get R by N minus A by N is 0. Right? Or more formally, R by N is equal to A by N. That is your vector equation of the plane. Right? Of course, we'll know N, we'll know A, and R is any random point. So this could be written like this, remember? R is any random point, right? R is any random point, so that'll be X, Y, Z. N is the perpendicular vector. Let's call it alpha, beta, gamma. And when you multiply E by N, right? When you multiply E by N, you will get some value. That's not I'm adding these two people. Yeah. Right? When you multiply this out, you will get some value. That's called it T. So alpha x plus beta y plus d, sorry, alpha x, beta y plus gamma z is equal to d, right? This is the Cartesian form, right? This is the vector form, right? And I'm going to show you how to do it now, right? Copy it up. And just a little idea where it came from, right? So you'll know what you're using now. Right? So this is the vector form and this is Cartesian form, right? Let's do some examples. I'll show you how to, right? Well, any unit one multiple choice 2022. I have it somewhere. Anybody have it close by? Send it to me if you have it. If you have it, just send it to me. I think I have unit one. I think I have it. Paper 1 year 2022. All right, that's 5 9 Okay, so this here is your vector equation of the plane. This version here is the vector. I'll show you how to get it. This version here is the Cartesian. So mark also level. Yes, now. Ready for the first one? Are you ready? Let's just try this one here. A plane passes to the point. A plane passes to the point. A plane passes to the point. Five, 1, 2. 5, 1, 2. And a plane passes to the point 5, 1, 2 and is perpendicular. And is perpendicular to the vector 3, 2, minus 1. And it's perpendicular to the vector 3i minus 2j plus 1k. Right? 3i minus 2j plus 1k. Find the vector equation of the plane and the Cartesian equation of the plane. Find the vector equation of the plane and the Cartesian equation of the plane. Find the vector equation of the plane and the Cartesian equation of the plane. Right? So everybody identify with A. A is the point on the plane, and the point on the plane, you can write it like this. Right? 5, 1, 2. And they give you the perpendicular vector. So you know what n is. N is 3 minus 2, 1. Right? So to get the vector equation of the plane, right? Let's start with the vector. To get the vector equation of the plane, all we have to do is use a little formula there, R, right, by n is equal to E by n. As I said, R is any vector, right? So it's R by n is 3 minus 2, 1. Is 5, 1, 2, and is 3 minus 2, 1. Right? Okay with that? So you just plug it into this formula, right? So it will be the vector form will stay like this, R by 3 minus 2, 1. Actually, write it like this, 3i minus 2j plus k. Then you work this out. So we work out this product, right? 5 by 3, 15. 1 by minus 2, 2 by 1. So you will get 50. That is your vector form. So this here is your vector form. Then you want to get a Cartesian. To get a Cartesian, you come back right here. You come back right here and you write x, y, z by 3 minus 2, 1 is equal to 50. So you multiply this out, you will get 3x minus 2y plus z is 50. This here is your Cartesian. Check it. Any questions? Questions earlier? The hardest thing is just to figure out what E and what is N. That's it. Right? Once you figure out E and N, you're good to go. Copy down. Let's do our next one.
Sir.
So that is 15 plus 2 minus 2. Yeah, 15 minus 2 plus 2. 15 minus 2 plus 2. Where did 2 come from? Right, I just multiply here. I multiply 5 by 3 again. 15. 1 by minus 2, 2 by 1. So I found the dot product right here. That's okay? Yeah. All right, copy down. Let's try 2017. I'll share this now again. Joel, Justin. All right, but so much noise doing. The products, yeah. But remember, we expand now that here is 0. Right? If you find AR and multiply by N, you'll get 0. We don't have AR, we just have A. So when you multiply this, you wouldn't get 0. Right? That's a little bit different. This is the proof that we use to get the equation. So we're using this to obtain everything. Right? So if you find AR and you multiply by N, you will get 0. All right, but we do have AR. All right. Right, let's try 2017, number 4. You see that? Right, find PQ and then find the Cartesian equation of the plane through Q and the perpendicular. Time when you're ready. I just get PQ again. I just get PQ. Huh? Well, to be specific, PO to OQ. PO plus OQ. Right? And then we'll use it to find part to touch the new topic that we do. So back to the equation of a plane. When it combine lines, you'll get a plane. Now. Right? So you have a plane, real easy. You get the equation of a plane, you take the point on the plane and the perpendicular vector. Remember how you had a parallel vector for the equation of a line? So you're using a point on the plane and the perpendicular vector, and it is multiplying. Right? You're multiplying the point by the perpendicular vector and the perpendicular vector by the random point R. R is X, Y, Z. Look at this example here. You have a point and the perpendicular vector. So you multiply A by N, right? And then you multiply R by the perpendicular vector. So you're using this formula here. R by the perpendicular vector is equal to the point by the perpendicular vector. That's the mixture. Right? So you take down this more important, right? Right, find PQ and then find the perpendicular vector there. Yeah. R by PQ is equal to, well, Q by PQ. PQ, yeah, that's it. So you can come to class later, yes, come to class 6 over, and you go to, yeah. Half an hour and you wrap it up. The winner. The winner. Oh, I thought that it's like a tournament going on. Oh, yeah, the picture. You got picture. Short one lab now, so I'm trying to figure out. Just take a picture of me and you got the board with the just take a picture. Where? Wait. Just correct yourself. All right, let's see what we got. All right, so PO is -3 -1 -2. OQ is 1 -2 4. -3 plus 1, that's -2. -3 2. Right, so you have PQ. Now you want to get a Cartesian form, so you're using R by N is equal to A by N. All right. Right, so R is X, Y, Z, and is perpendicular vector. They said it's perpendicular to PQ. So you write in PQ -2 -3 2 is equal to A. A is the point Q, right? They gave it A here. So that's 1 -2 4. And then N is equal to -2 -3 2. So when you multiply this out, you'll get -2x -3y plus 2z is equal to -2 plus 6 plus 8. Right? That's 10. 10 or 12? 12. So therefore, the Cartesian equation of the plane is -2x -3y plus 2z is 12. Anybody confused there? Yeah. Somebody multiply wrong here. Emily, check it back. Oh, I didn't change the signs. Okay, yes. So I make a mistake there. All right, Rika, good. Shannon, good. Keelan, good. Anybody confused? All okay with that? Tabara, all okay? Yeah? Copy down quick and let's take a look at something a little bit harder. Suppose I give you 3 points now. Suppose I gave you a plane. Suppose I gave you a plane and I gave you 3 points on the plane, A, B, C, 3 random points. That's all I give you. What you would do? Any ideas? We already have a point on the plane, right? What else we need? Right? We already have a point on the plane. We need something perpendicular, right? So we do have anything perpendicular. Just now, we can listen to that. Right? Here's what we could do. We could find AB. We could find AC. Sorry, AC. Anyone you could find actually. And then we can make up some perpendicular vector N. Let's call it A alpha beta gamma. And then we can say that N multiplied by AB is 0. Then we can say N multiplied by AC is also 0. And then solve them to find values for alpha beta gamma. I'm going to show you now, but that's basically what I'm doing, right? I'm going to find AB and AC, right? And I'm going to multiply it by some unknown vector, right? And then use the perpendicular rule, dot product is 0. And then try and solve for everything. Are you okay with that? Well, they're probably not okay with it, but I'm going to show you now. All right. So next subheading, vector equation of a plane. vector equation of a plane given 3 points on the plane. Given 3 points on the plane. Given 3 points on the plane. All right, so I'm going to work with the first example here with you. Suppose I gave you a little plane. Right, and on that plane, I gave you A, B, and C, right? Let's make up some values. It don't matter, right? Because they're non-linear, right? -1, 1, 3. Sorry, it's a coordinate, right? So that's -1, 1, 3. B is equal to what? What do I want to write? Let's use 4, 3, 2. That can work. And let's use C. What do I want to use for C? Let's put some minus values now. -2, -3, -1. All right. So first thing I'm going to do, I'm going to find, I have some unknown vector n here, right? That vector is perpendicular to this plane. I don't know what n is. N is something perpendicular. Let's call it alpha for now, beta, gamma. Okay, so step number 1. Step number 1, we're going to try to find AC. And then we're going to try to find AB. So AC is A to O plus O to C. So A to O is 1 - 1, 3. O to C is -2, 3, -1. So when you add it up, you will get -1, 2, 2. Right? That's the AC. And then we're going to find AB. It don't matter. Eh? You could find BC if you want. It don't really matter. So we're going to find AB. AB will be 1 - 1, 3. Make a mistake there. What did I say? -1, 1, 3. Sorry. I forgot to put the minus sign there. So that's -4. So that's 1 - 1 -3 plus B. B is 4, 3, 2. So we get in 3, 2, -1. That's the AB, right? So we have AB and AC. I'm trying to fit everything here all this one. All right, take a 2 minutes, copy down there. Huh? Oh, thanks. Bye. Sorry. Remember, n could be any perpendicular vector, right? It's not one specific vector. It could be anything. I want to show you how to get that vector. So you find AC and AB. Right, so we have AB and that. Right, so since n is perpendicular to the plane, it means that n, the vector n, multiplied by AC should be 0. So it means that alpha, beta, gamma multiplied by -1, 2, -4 is 0. So it means that minus alpha plus 2 beta minus 4 gamma is 0. Right? Let's call that equation 1. Then the same thing, n multiplied by AB is also 0. So alpha, beta, gamma multiplied by AB. AB is 5, 2, -1 is also 0. So it means that 5 alpha plus 2 beta minus gamma is 0. Right? So all I did is apply the rule, and I'm going to try to solve that simultaneously now. Copy that down. Right, so I'm going to try to solve that simultaneously. Finish? Changing this, right? So we're going to attempt to solve this now. You can just call them over for me, please. You can just call over the equations there. Minus alpha plus 2 beta minus 4 gamma is 0. And then next is what? 5 alpha plus 2 beta minus gamma. Right. So we're going to attempt to solve this. So watch closely, right? Watch closely. Because remember, we have 3 variables and only two equations, right? So it means that we're going to have to choose one of the alpha, beta, or gamma as a variable. So I'll show you what I mean, right? So let's take equation 2 and minus equation 1, right? 5 alpha minus, so a minus in, let's leave it right there and minus it just like that. 1 minus 2. So I'll put in a minus sign here, right? Minus alpha minus 5 alpha minus 6 alpha. 2 beta minus 2 beta is 0. Minus 4 gamma minus gamma is minus 3 gamma. 0 minus 0 is 0. Right? What does that simply mean? It means that if I make gamma the subject, I'll get 6 alpha is equal minus 6 alpha is 3 gamma. Therefore, gamma is equal to minus 2 alpha. You see enough? Are you sure? So we know alpha gamma is minus 2 alpha. And so if we let's pick a letter. Let's pick the letter what? P. So if we let alpha equal to P, here's what we have. We have alpha is equal to P, gamma is equal to minus 2 P, right? Remember this here? And let's try to find for gamma. So minus, I'm going to try to find for gamma, right? So from equation 2, gamma is equal to 5 alpha plus 2 beta. Gamma is equal to, are you using this here? Are you using this here? We're almost done, we're almost done. 5p plus 2, oh gosh, sorry. I'm supposed to make beta the subject. Because we already have alpha and we have gamma. So I'm supposed to make beta the subject. So from equation 2, 2 beta is equal to gamma minus 5 alpha. Okay, so beta is equal to alpha minus gamma minus 5 alpha all over 2. So therefore, beta is equal to, substituting gamma now, minus 2p minus 5, substituting alpha all over 2. So you're getting minus 7p on 2. Right? After. So therefore, n is equal to, remember I told you n is alpha, beta, gamma. So we know alpha is p, we know beta is minus 7 on 2p, and we know gamma is minus 2p. Right? So we now find that perpendicular vector. Right? 10 years later, we have it, but we still do have a point. What you could do here is put any value you want. So you could put p as 2. Any value you want, it don't matter. Any value put in there will be perpendicular to all the points there. Right? So if you put p as 2, you'll get 2 minus 7 minus 4. That's it. That's how you get the perpendicular vector. Right? I know it's a little long. Right? It never came before, but I still have to show you it, right? It never came before, but I still have to show you. Right? Copy it down. We have time because freeze in one. One more. Huh? All right. I'm gonna send it now on the group though. All right, online. All right, online. So that's it there. You all can log out, right? But you all follow what to do. It's a little challenging, right? But basically, you find AB, you find AC, you use the product perpendicular rule, and you get two equations and you solve, right? One of them will always be a constant.